In Objective 5, we start throwing pretty much everything at you all on one worksheet. So there's a few things we need to remember about the equation is going to tell us a lot about the parabola. So if you have an equation that has y to the first power and x to the second power, so you've solved for y equals x squared. You know that's going to give you a parabola that goes up. Now, y equals negative x squared is going to give you a parabola that goes down. Now, on the other hand, if the equation solves for x equals y squared, you know that's a parabola that's going to open to the right. And if it's x equals negative y squared, it's going to be a parabola that opens to the left. So one of the things you're going to want to figure out is what variable am I solving for in the equation? And it's always going to be the first power variable. Let the variable that's squared do all the talking. Solve for the first power variable. And then the other very important concept is c equals 1 over 4a. Now, also, when you move horizontally, anytime you're moving horizontally on the graph, it's the x value that changes, the x coordinate, but the y stays the same. When you move vertically, it's the exact opposite. It's the y value, the y coordinate that changes value, while the x coordinate stays constant. So my first example, some of you guys are okay with the parabola in this form. Some of you aren't. So I'm going to change it to the form most people are comfortable with. We know ultimately we're going to solve for y because that's the variable that's getting the first power. So the first thing I've got to do is get rid of that leading coefficient of 8. I could say divide both sides by 8, but I'm going to say multiply both sides by 1/8. So what you're going to have is 1/8 x plus 4 squared equals, now that got rid of the 8, really all it did was it moved it from this side over to that side, and now I have y plus 1. Now I'm only one step away from having y by itself. I'm going to subtract 1. And I'm going to write the equation starting with the y. So y equals, I've got my 1/8 x plus 4 squared. And then it would be minus 1. So now I've taken the equation into this descriptive form. And the reason it's called descriptive form, I know a lot about this parabola now that I'm in this form. I know y equals 1/8 x squared. The 1/8 is positive. So I already know this parabola is going to open up. And I also know because of the 1/8 that it's relatively speaking, it's a wide parabola. And I also know something else. I know the vertex is at -4, -1. So I'm going to put all of that information together. I'm going to make a vertex. I'm going to leave the x and the y axis out of it because it really just gets in the way. So let's say this is the vertex at -4, -1. I also know it's an open wide parabola, so let's make a parabola that opens wide. All right, I also know there's a focus on the inside and there's a directrix on the outside. And I know that they are equal lengths. Whatever it takes to get to the focus, it takes the exact same length behind the parabola or in back of the parabola to get to the directrix. Now the big question is, what is that length? because I need to know that length. Well, that's where the equation c equals 1 over 4a comes in. Because when we put the equation into this form, now I know that a is 1 over 8. So c equals 1 over 4 times 1/8. Now what that means is c equals 1 over 4 times 1 is 4, so that's 4 over 8. So c equals 1 over 4 over 8 is reduced to 1/2, and 1 over 1/2 is 2. So c equals 2. Now that's going to help me find my focus and my directrix, because when I move vertically, it's the y-coordinate that changes, the x-coordinate stays the same. So if I was at -4, -1, and I moved up 2 spaces, let's put the vertex first, -4, -1. So we know we've answered that already. If I was at -4, -1, and I took 2 steps up, well, that changes my y-coordinate from -1 to +1, because -1 plus 2 is +1. So that makes my focus at -4, +1. And I can mark it if I want, -4, +1. Now, I move the exact same space backwards to get to the directrix. So if I'm at -4, -1, and I drop 2, that would be -4, -3, but the directrix is the entire line, not just a point. So y equals -3 is the directrix. Now, the last thing I have to do is find the focal chord endpoints. So from the focus, I'm going to go out this way, and I'm going to go out that way. And that relationship is 2c. So if c equals 2, then 2c must equal 4. So that's what I'm going to do. If I'm at -4, 1, and I move 4 spaces to the left, well, that means my x-coordinate is going to change, my y isn't, and that would put me at -8, 1. And if I moved 4 spaces to the right, that would put me at 0, 1. In this example number 2, you can see I'm going to be solving for x, because it's the x that has the first power variable, and it's y that's being squared. So the only thing I'm going to do to get rid of this -16 is I'm going to multiply both sides by 1 over -16. Now all that's going to do is put -1 over 16 in front of the y plus 5 squared plus 3. Now, I could put the equal x right here, but I kind of like it better right there. Now, I know a lot about this. X equals, when I'm solving for x, the parabola either opens to the left or to the right. Since this is negative, it's going to open to the left. I also know my vertex is already 3, -5. Now, don't get this backwards, because see how this is y plus 5 in parentheses? Whatever's in the parentheses is always opposite, and whatever is afterwards at the end of the equation is always the same. So the y-coordinate of the vertex is -5. So let's go over here to vertex, and let's put -5 in the y-coordinate. And then the x-coordinate of the vertex is positive 3. So let's start figuring out what we've got here. We have a vertex at 3, negative 5. Let's just call it right here, just to get a picture of it. 3, negative 5. We know the parabola opens to the left because of this negative 1/16, and again, we know it's relatively wide, but so there we go. So that means there must be a focus somewhere in here, and there must be a directrix in the back of the parabola equal distance to the focus. So whatever distance the vertex to the focus is, it's the same as the vertex to the directrix. So I'm going to make a pretty good educated guess. Okay, so we've got there. Now, those two distances depend on the value of c. So remember, c equals 1 over 4a. So c equals 1 over 4 times the a value of negative 1/16. So that would be negative 4 over 16, 1 over negative 4 over 16. Now, if I reduce negative 4 over 16, that's negative 1/4, 1 over negative 1/4, and 1 over negative 1/4 is negative 4. So, c equals negative 4. And the negative simply means I'm going to go to the left to find the vertex instead of going to the right if it were positive. So if I'm at 3, negative 5, and I go 4 units to the left, I'm at negative 1, negative 5, because when you move to the left, you affect the x-coordinate. So 3 plus negative 4 is negative 1. So I would be at negative 1, negative 5. Now, if I go those exact same 4 units to the right, if I was at 3, negative 5, and I went to the right 4 units, I'd be at 7, negative 5. But the directrix isn't a point, it's the entire line. So that would be x equals positive 7. Now the last thing I have to do is find those two focal chord endpoints. If I went like this, and I went like that, what would be those 2 points? Well, I'm moving from the focus, so it'd be nice to remember what my focus was. It was negative 1, negative 5. And this unit is dependent on the distance of 2c. So if my c was negative 4, then my 2c equals negative 8. And since we're just talking distance anyway, you could think of the absolute value of negative 8, which is 8. So if I was at negative 1, negative 5, and I dropped down 8 units, dropping down would affect the y, and if I'm already at negative 5 and I subtract 8 more, I'm at negative 13. So this would be negative 1, negative 13. That would be one of my focal chord endpoints. Now, if I did the exact same thing, started at negative 1, negative 5, and I went up 8 units, well, negative 5 plus 8 is positive 3. That would put me at negative 1, positive 3. And those would be my focal chord endpoints. I'm going to use the formal definition of a parabola to write the equation of this parabola. And the only thing we know right now is the focus is at 6, 5, and the directrix is at y equals -9. So I marked both of those things. There's my focus at 6, 5, and there's my directrix at y equals -9. Now, knowing those two things, I can figure out a couple of other things. The vertex is halfway between the focus and the directrix, so I eyeballed it and put my vertex right there. And I also know the focus is on the inside of the opening of the parabola, so I know the parabola opens up. So I was able to make a sketch of the parabola simply by knowing the focus and the directrix. Now, the formal equation of a parabola means every point on the parabola is equally distant from the focus to the directrix. So I just picked a point right here, and I put it in black. I have no idea what the coordinate of that point is, the ordered pair. So I'm just going to put x, y. Now, you can see what I did as far as, connecting that point to both the focus and the directrix, just so you can see with your eyes what's going on. Now, I am going to add one more piece of information. I'm going to add that point that's right down here. Now, I don't know what the x-coordinate is of this point, but since this point is directly below it, it has the exact same x-coordinate. And I do know what the y-coordinate is of this point because it lies on the directrix y equals -9, so I know the y-coordinate is -9. Now, I'm going to use the distance formula and the idea that this distance equals that distance. So I'm going to set up the equation on this piece of paper, and then I'm going to do all the rest of the algebra on another piece of paper. So the distance formula, I'm going to work on this part first. The distance formula would say that this x minus 6 quantity squared plus this y minus 5 quantity squared. That would be the distance from this point to that point. But by the definition of the parabola, we also know that distance equals this distance. So I'm going to do the same thing, only with the other connection. This would be x minus x, which is very conveniently going to go away in a second, squared, plus, and this would be y minus -9 squared. So that's going to be the setup. The rest of my problem is purely algebraic, but it came from the fact that this distance equals that distance. Okay, so let me copy what I've got. I have the square root of x minus 6 squared plus y minus 5 squared equals, and this one was x minus x squared plus y minus -9 squared. Okay, so I'm picking it up where I left off with the drawing. Now, the first thing I'm going to do is I'm going to do quite a few things at once. I'm going to square both sides to get rid of the square roots. Now, that just leaves x minus 6 squared plus y minus 5 squared equals. Now, x minus x is 0. 0 squared is 0. And y minus negative 9 squared would simply be y plus 9 squared. Now, the next thing I'm going to do, I'm going to start expanding everything. This would be x squared minus 12x plus 36. I really didn't need to do this, but I did it. I do need to do this plus y squared minus 10y plus 25 equals, and then over here, y squared plus 18y plus 81. So I just did a lot of foiling in my head. Now, I've got y squared over on this side and y squared over on that side. If I tried to move this one over there, they would both cancel each other out. So I'm just going to do this. I'm going to add my 10y here, and I'm going to add my 10y right here. Notice I don't have any more y squareds in the problem. And I'm going to subtract 25 right here, and I'm going to subtract 25 right here. Now, algebraically, I'm now at this point. Remember I said I really didn't have to do this because it was a perfect square in the first place? Well, I'm just going to turn it back into its perfect square of x minus 6 squared equals. Notice there's nothing else on the left-hand side. Now, this would be 28y. I'm combining like terms. And then this would be 81 minus 25 is 56. Now, I'm going to say x minus 6 squared equals, I'm going to factor a 28 out. And I'm going to get y plus 2. Now, depending on what form they want, this could be the correct answer right here. This is the equation of that parabola. But if we wanted the y equals form, the descriptive form, I'm going to now multiply both sides by 1 over 28, and this would be 1 over 28 x minus 6 squared equals y plus 2. That would be how I got rid of that 28, was by multiplying both sides by 1 over 28. Now, if I wanted y equals, the only thing hanging around with the y now is the plus 2, so I would subtract 2, and I'd get 1 over 28 x minus 6 squared, and when I bring it over the other side, it's minus 2 equals y. Or if you like the y being first, y equals 1 over 28 x minus 6 squared minus 2. So that would be the descriptive form of the parabola. And since it's in the descriptive form, you also know the vertex is at positive 6, negative 2. And if you look back at the drawing, remember how we just estimated where the vertex was? We now know that that's positive 6, negative 2. In this last example, I'm going to show you how to write the equation of a parabola in the different method. Instead of using the formal definition of the parabola, which uses the distance formula, and it's very, very algebraic. There's another way of doing it, and it doesn't involve anywhere near as much math, but it's very intuitive. There are a lot of relationships you have to discover on your own, and then you have to understand what those relationships mean. So, here we have a problem where the focus is at negative 1, 7. So you see I already marked it, negative 1, positive 7. So there's where the focus is, and the directrix is at x equals 5. Well, the first thing you probably see, it isn't an up-down parabola. It's actually one that goes to the left, because we know halfway between the focus and the directrix is the vertex. So I'm just going to eyeball it right now, and I'm going to say about halfway between these two locations is about right here. So then I'm just going to open the parabola like this. Okay, so now we have an idea that this is definitely a left parabola. So it's going to take the form of x equals. Now here's where the very intuitive stuff comes in. The next thing we have to do is we have to find the location of this vertex. Now, the horizontal distance between the focus and the directrix is what we have to deal with next. So remember, it's a horizontal distance, so all we care about are the x coordinates because that's the way you move left and right. So if this x coordinate is at -1 and the directrix is at x equals 5, really what you're discovering is what is the distance between the focus and the directrix. So you could either do -1 minus 5, which is -6, but distance is always positive, so then take the absolute value of that, and you would simply get 6. Now, you would get the same thing the other way if you went 5 minus -1, but it would be 6 in the first place because that's 5 plus 1 and you would get 6. So, either way you look at it, the horizontal distance between the focus and the directrix is 6. Now, the next thing you have to remember is the vertex is halfway between. So, take that 6 and divide by 2, and that tells you you have to take 3 steps. And it really doesn't matter which way. Let's go from the focus. If I took 3 steps to the right to get to the vertex, I'm at -1, 7. This would be 0, 7. This would be 1, 7. This would be 2, 7. So now I know where my vertex is. It's at 2, 7. Well, there was something else about those 3 steps. When we took those 3 steps either way, that was actually the C value, because that's the relationship among parabolas. The distance from the vertex to the directrix and the vertex to the focus is the C. So what we know is C equals 3 in this problem. We also know that relationship that we've been using a lot, C equals 1 over 4A. So if I substitute, I've got 3 equals 1 over 4A. Now if I cross multiply, that means 12A equals 1. So A equals 1 over 12. Now put all that information together, and that's going to give you the equation of this parabola. So remember, in the first place, it's a left parabola, so it begins with x equals. Now the next thing, since it opens to the left, that A value is actually negative. -1/12. And then something goes in here and something goes in there. Well, in order to have a y coordinate of 7 in the vertex, this would have to be y minus 7. Because remember, it's always opposite in here, and it's the same as out here. So I'm going to put plus 2. And that's the equation of this parabola. There's a lot less math involved because we really don't use the distance formula, but there's a lot of relationships you have to remember. Okay, spiraling back to circles one more time in this objective. Find the center and the radius. Well, simply by the instructions, you probably understand this is a circle, but why is it a circle? It's because both the x and the y are presented with squares, and the leading coefficients are the same. They don't always have to be 1. They just need to be the same. Now, the first thing I'm going to do to this problem is I'm going to make it easier by making these leading coefficients back to 1. If you notice, every single term in this polynomial is even, so I'm going to divide everything by 2. I'm going to even divide the 0 by 2. Now what that's going to do is it's going to make the equation of the circle have leading coefficients of 1 for the x squared and the y squared. So now I'm going to do what no, I'm not. I'm going to go x squared plus y squared plus 8x minus 2y plus 3 equals 0. So every single term got divided by 2. Now I'm going to do what I've done before. I'm going to group the x's together, and I'm going to get that 3 over to the other side. So it would be x squared plus 8x, and then I'm going to leave room for that third term that completes the square. And I'm going to put plus y squared minus 2y, and same thing. I'm going to have that third number that completes the trinomial for the y's, and then I'm going to start with negative 3 on that side, but I know I have to add the sum of those two numbers. So now, let's figure out what that is. I'm going to take half of that 8, and it becomes a 4, but then you square it, and it becomes 16. I'm going to take half that negative 2, which is negative 1, and square it, and it becomes positive 1. So, if I added 16 and 1 over here, that simply means I need to add 17 over there. And now I've completed my squares, so I have perfect squares. This would be x plus 4 squared. This one would be y minus 1 squared equals negative 3 plus 17 is 14. And now I can identify everything I have. The center of the circle equals negative 4, positive 1. And the radius is the square root of 14. And if I tried to simplify that, that would break down to 7 times 2, and I wouldn't find a pair of anything, so I'm just going to leave it right like that.